out all the radar signals coming to detect, and that cannot detect where the missiles is coming from. So like 100% surety is not there detection, but at least 60 to 65% is the probability to achieve the goal of the missile, so because of this plasma and the squeezer that control the thickness of the plasma around the missiles. So in the future wired, only radar system will not able to control the air defense system. We need to have a infrared sensing, plasma and other sensing, structure sensing to counter the stealth technology. If we only depends on the only radar system, so we definitely the game is over, because technology is changing and they are using the different, because Russia and China already prepare that missile which can create a plasma, a specific nano range plasma around the ballistic missile. So in this case, radar system is not useful because that plasma counter the radar system signal. So next. So for the, why the nanomaterials is important? Because this nanomaterials has a high surface area to enable materials property. Broadband performance means not narrow, broadband means here, because we are creating a hybrid material which can perform a very big, like megahertz to gigahertz frequency range, a tetrahertz frequency range, like that one. So we can, if someone is changing the different frequency range radar signal, so that materials can control that radar signal. If we are just creating a material which has a only megahertz radar frequency range, and suddenly we switch to the tetrahertz frequency range, so our system can detect it by the tetrahertz frequency range. So in the nanomaterials, we can change, increase the band of the suppressing the radar signal. So that's the thing. Now what are the materials I will skip because time. Here, so what are the, how these stealth layers prepare? Like we have many layers. So first of the like protective layer which can protect the corrosion and other things. That is the, then we have a top coated dielectrics layer which can absorb the, this dielectrics is not normal dielectrics, that is the nanodielectrics. I have included some result. This is not normal dielectric, like ceramic materials included in the polymer matrix and created dielectric. That is not, that is nanodielectric. Means like polymer, and like we know the two metal sheet and one insulating is the dielectric. But when the two, like carbon nanotube they mention, and in between carbon nanotube, polymer chain is the inserting. So that create the nanodielectrics. So this type of advanced materials used for the dielectrics. And then the layer magnetic like ferrite and something like spinel, like cobalt and other high performance alloy we can use. And sometimes we use the nuclear grade high performance ceramic material to improve the performance. And then aircraft structure, that is the layer how to they design. But only materials is not contributing the stealth performance, also the design, how they design the structure and angle and other things also is helping to the design the stealth technology. Next. I will go. So how to counter? If we switching the frequency, different frequency, switching the radar, and polarization means if like electromagnetic field is changing the sudden like 1,000, I have performed, this is my work, what I am doing currently. So I perform like 1,000 cycle per second, and that can counter the stealth technology. If suddenly we switching the cycles 1,000 cycle per second, 100 cycle per second electromagnetic frequency range, so stealth is like something failed to suppress that frequency range. And then I already mentioned multi-physics radar sensing to by like infrared and other plasma and other radar system we can use to improve, counter the stealth technology. Like multi-band radar like X-band, Q-band and polarization radar, passive radar, like we also use the passive radars inbuilt, means like we have a static radar system, airborne radar system, and in between passive radar system and multi-static radar system. Like so, like a system like a stealth aircraft in between room, and all the radar system covered by the wall of the room. So same like we can generate. So there is no chance to hide anything. I'm not only talking about stealth. I'm talking a stealth type missile system, all the things. Only I'm not covering the aircraft. This is the applicable for all type of stealth technology, whatever they using Russia and China, even currently using by the Iran. One more thing is there, why the Iran drone system is more useful and they're destroying the USA, because they are using the AI-based system. Because if we are sending one more factor, Iran-Israel war is the EN factor, efficiency factor. Efficiency factor means how much we resources putting in the system or how much we are getting output. USA using the THA and other missile system that like millions of dollars, and like Iran is using $20,000 unmanned vehicles. So if Iran is sustainable to run this one missile cost, Iran can fight the like 2 to 3 days. So that is the same thing. That how to discount this cost effective and AI fusion system means like if like one unmanned vehicle going to the territory and that's shut down. So whatever. All the network of the UV unmanned vehicles connected to each other, and they can transfer the AI data, where the missiles and where the air defense system is hitting them, or they can just share the data, and that data can because AI is not like thinking like that. They find a certain type of the pattern, and that pattern they analyze and give a data how to the output data is coming. So like that, they can give a short time of data where the defense system there and how we can change our trajectory path. So just like one is going like straight path, and they are finding like the AI system detected this path is not dangerous for the unmanned vehicle, so they can suddenly change the track and path of like one bullet is moving like snack, and other bullet is coming straight to hitting that one. So it's very difficult to hitting a straight bullet to the moving bullet. So same like system. So this system is achieved by the AI fusion system, where they gather the data and process the data and implement that one. So this is the AI fusion. I will skip because. So AI fusion system is lot of things is there, like filter data, gather the data, means like if they are using the 20,000 like drone, that shot down, but they are using those data that already shot down, but that drone is not useless, because that drone already gathered the data, projectile and trajectory of the upcoming missiles and others geographical scenario. That data sent to the others command center. A command center analyze the fuse response and process the data and analyze how to the we can drive the others unmanned vehicle and something like. So this is the fuse process response system, and this is
Dr. Raghavendra. We will limit it.
Just finish. Yeah. So this is the experimental validation. So here I developed the Maxine-based material. Here, second, whatever I use the nanodielectric. Mostly everyone know here, when we putting the nanomaterials in the polymer composite, TG always increase, but here TG is decreasing. That interesting thing. So that is the created by nanodielectrics. Then third is the EMI shielding I measure. That is the thickness variation EMI shielding. And that I have one video. Here I track the nanomaterial, how the nanomaterial moving in the system. So here dynamics I study. Here I snapshot the dynamics of the system. Here I developed the bromine system, already new materials. In India, I developed, first person who developed the bromine. And I sent this bromine to the Stanford. So they process that. Then here I develop some materials, because here you can see the spherical thing. I here a sticky-like fiber-like structure I developed with the help of the nanomaterials. Here fibers and also selective localization of nanomaterials and system. And you can see EMI shielding I improved. And here real permittivity and other property, whatever nanomaterials you use for the EMI shielding steel technology. So here the MWS is the Maxwell-Wagner-Sealer effect, mostly important for the stealth and polarization effect. And this is the future research, whatever I am doing. This is all this PPT related to my research work, whatever currently I am doing. And I extracted little data from there and explain here. This is the, this is my future work, what I'm going to do in the next couple of months. And thank you.
Thank you.
Can I review? Pen drive.
Thank you, Dr. Raghavendra. We did not get as much information about the Iranian drones from Republic TV, jitna aapse mila hai. Thank you very much. All the dignitaries, ladies and gentlemen, our panelists have finally presented their pitches. Any questions from your side will be welcome now. Sir, please. Marshal Lawrence, please.
Since morning, we have heard a lot about additive manufacturing. I wanted to ask this question to Dr. Kamath, but I couldn't meet him. He had to rush back to his office. So I would request this question to be answered by DRDO, Dr. Sanjeev Kumar, Industry, Mr. Sanjeev. Mr. Balpreet, I would request you to give the worldwide perspective that without certification we cannot go ahead and utilize the additive manufactured parts in aviation, especially the critical areas. Non-critical is still fine, and in hot zones I don't think even worldwide 3D printed parts are being used. So what is the way ahead? What are the world trends, and what is industry thinking? What is DRDO doing to evolve a certification system? Are we studying any international standards? Are we setting up a committee? Are there any efforts being made by any lab or any other enabled body to move forward in this direction? Thank you.
Dr. Sanjeev, you would like to start on this?